In lesson 3.6, we're going to be talking about lines in the coordinate plane. We're actually going to break this lesson into two parts. So today we're going to talk about part 1. In part 1, we are going to discuss the equation of our line. The equation of our line can be written different ways, and therefore we have different forms of our equation. The first form that we're going to talk about is called the slope-intercept form. And I happen to feel that most of the time, this is the equation kids are most familiar with. It looks as y equals mx plus b, where m is the slope of my line and b is the y-intercept. I'll remind you that the y-intercept is where your line crosses the y-axis. So as I look over to the right, I see that this equation here is written in slope-intercept form, and we substitute numbers in for m and b. So here, this tells me that my slope is 2, or 2 over 1, and that it would cross the y-axis at negative 3, because that would be my y-intercept. M is 2, and b is negative 3. The second form that we're going to review is called point-slope form, and it is just that. It has a point and it has the slope. So when you look at the equation of that line, y minus y1 equal to m times the quantity x minus x1, the point on my line is going to be x1, y1, with the slope of m. So as I look over to the right, my equation here has been written in point-slope form. And the point on my line would be the point negative 4, 2. And my slope here, where m would be 1/2. The last form that we're going to review is called a standard form, and in standard form it looks typically written as ax plus by equal to c. It says where a, b, and c are real numbers and a and b are both non-zero. So as I look over at the right, this equation is written in standard form, 2x plus 3y equal to 10. However, when written in this form, I cannot quickly identify my slope or a point on the line. I would have to do some rearranging. Looking at example A, we are going to start by taking our information and writing our equation in slope-intercept form. So as I look at number 1, and they tell me that my slope is 3, and it contains the point 0, negative 5. I'll remind you we're wanting it in the form y equals mx plus b. Well, I can see I'm going to substitute in my slope is 3, and it contains my point 0, negative 5. But after closer evaluation, I know 0, negative 5, that's actually my y-intercept. So all I really have to do is plug in for those numbers. So in slope-intercept form, we would have the equation y equal to 3x minus 5. And that would be my final answer. As I look at number 2, I do see that they give me a slope of 5. And this time they say it contains the point 1, negative 3. So this is not the y-intercept. So I cannot go ahead and plug in for my b value right away. I'm actually going to have to do some solving or some rearranging. And there's two ways you could go about this. Because they give me a point and a slope, I actually am going to put it into point-slope form. Point-slope form, well, if I take my point it would look as so: y minus negative 3 equal to 5 times the quantity x minus 1. If I wanted it in slope-intercept form, I really want y by itself. So I'm going to do some simplifying. I'm going to add the opposite, and I'm also going to do some distributing. I would find y plus 3 equal to 5x minus 5. And now to get y by itself, I'm simply going to subtract 3 from both sides, and we would be left with y equal to 5x minus 8. And now I have it in slope-intercept form, knowing my slope is 5 and it is crossing the y-axis at negative 8. Now the other way to do that is we could have taken our x, y, and used slope-intercept form by saying that negative 3 as my y equals 5 times 1 as my x plus b, and I could have solved it for b and then plugged it back in. Obviously, we should end up with the same answer, and here I'm finding out that negative 8 is b, and we would plug it into our equation. So there are two different ways you could go about that. In example B, when they ask me to write my equation of my line, this time I'm going to look at writing it in point-slope form. Point-slope form here, well, they do give me a slope of negative 3/4 and a point of negative 2/5. I'm going to use this as my x1, y1. Now, point-slope form, well, we're taking y minus y1 equal to m times the quantity x minus x1 and substituting in our numbers. Y minus 5 equal to a negative 3/4 times x minus a minus 2. I'm going to go ahead and simplify. This would be my final answer in point-slope form. I don't have to do any distributing or simplifying beyond that. But you'll notice in number 2, I actually have 2 points for my line, negative 7/4 and 9, negative 4. What I don't have is the slope, right? So I need to go ahead and first find my slope or solve for my slope. So we'll use what we learned in lesson 5, where we took y minus y over x minus x. Okay, I find out that my slope is negative 1/2, so that's what I'm going to use as my m value. Now if I'm using point-slope form here, I see I have 2 points. I can actually pick one or the other. It does not matter. So one possible answer, if I pick the first point, would be y minus 4 equal to negative 1/2 times the quantity x minus a minus 7. Or I could use the second point, and we could say y minus a minus 4 equal to negative 1/2 times the quantity x minus 9. And while these equations look different, they would actually graph the same line. If you graph them on your graphing calculator or graph them on paper, this would be the same line. Okay, looking at the back, finally example C, they're asking me again to write my equations of my line in slope-intercept form, identifying the slope and the y-intercept. Looking at the equations, I can see, well, these are actually written in standard form. I have negative 10x plus 2y equal to negative 6. Well, if I'm going to get this in slope-intercept form, I need to be able to solve and to get my y value by itself. So the first thing that I'm going to start with number 1 is I'm going to get my x's on the other side. So I'm going to add 10x to both sides. We'll have 2y equal to. Now 10x and negative 6 are not like terms, so I can't add them together. I'm actually going to put my x's first. And now I can see to get y by itself, I would simply have to divide by 2. But I have to make sure that I divide everything by 2. And so in slope-intercept form, we find out that y equals 5x minus 3. What does that tell me? Well, my slope would be 5, or 5 over 1, and my y-intercept would be negative 3. I'm going to approach number 2 the same way. I'm going to start first by moving my x's to the other side. Now again, negative 3x and 10 are not like terms. I will then divide by negative 5, but I need to make sure I divide everything. And so in slope-intercept form, this is going to be y equals 3/5 x minus 2. My slope then being 3/5 and my y-intercept being negative 2. Next, we're going to review our horizontal line or our vertical line. When we talk about a horizontal line, it's a little bit hard to see here, so I'm going to go ahead and highlight. We said before that our horizontal line has a 0 slope. So what's the equation of my horizontal line? Well, let's start by looking at some of our points here. If I look at some points on my line, I can see my first point I would be at negative 3, 1, or negative 2, 1, or crossing the y-axis, 0, 1, and so on. What do we notice? We're always 1 unit up from the x-axis, right? Our y value is always going to be 1. So the equation for my horizontal line is simply going to be y equals 1. In fact, any horizontal line will simply be y equals, and whatever that, however many units up or down you are. Similarly, my vertical line here, well, before we said a vertical line actually has an undefined slope, because I can't have division by 0. But as I look at the points on my line, here, I would say, okay, negative 1, 2, negative 1, 1, negative 1, 0. What do we notice? We are always 1 unit to the left, or our x value is always negative 1. And so here, my equation for my line is going to be x equals negative 1. And any vertical line, my equation should be x equal to the numerical value. So in example D, when they ask me to write the equation of a line that has a slope of 0 and passes through the plane 4, 6. Well, slope of 0 is telling me that this is horizontal. And so if it is a horizontal line and I'm thinking about the point 4, 6 over 4 up 6, I'm going to know I'm always going to be up 6 units. My equation would simply be y equals 6. The equation of my vertical line passing through the point negative 3, 4, again, negative 3, 4 here. Well, vertical line, I'm always going to have to be 3 units to the left, and so my equation is simply going to be x equals negative 3. We talked a little bit in lesson 5 about parallel lines, and we talked about the fact that our parallel lines have to have the same slope. So it is easiest to determine lines parallel when we can quickly identify their slope. So a lot of times you're going to compare these when they're written in slope-intercept form. So for example, we know that if we had y equals 3x plus 8 and y equals 3x minus 3, these are different lines, but they're definitely parallel because they have the same slope. I'm able to identify that they're both written in the same form. Intersecting lines are going to have different slopes. And so if I gave you the example of y equals 3x minus 5 and y equals 7x plus 2, these lines clearly not parallel, and if they're not parallel, they're going to intersect. Now we did say in our previous lesson that if they were perpendicular lines, then the slopes were opposite reciprocals. Coinciding lines. An example of a coinciding lines, well, y equals 5x minus 4 and y equals 5x minus 4. Coinciding lines are actually the same line, one on top of the other. Sometimes you might see the second equation written something like this. 2y equal to 10x minus 8. And with a little simplification here, we would see, okay, solving for y, we would get y equals 5x minus 4. In example E, they're asking us to determine if our lines are parallel, intersecting, or coinciding. So the first thing that we want to do is we want to make sure we're comparing them written in the same form. We have to compare apples to apples. And if I look at number 1, they are written in the same form. I'm going to look at their slopes here. I see that number 1, my first equation has a slope y equals 3x plus 7, slope of 3. Y equals negative 3x minus 4. Now, these slopes are not going to be the same, and so different slopes, different equations on my line, these are going to be intersecting. Are these lines parallel? No, they're not parallel because 3 and negative 3 are not opposite reciprocals. Sorry, not perpendicular. When I look at number 2, I see, well, I have 2y minus 4x equals 16, and y minus 10 equal to 2x minus 1. For my comparison purposes, I actually can't say much about these because they're not written in the same form. So I'm going to do a little bit of rearranging, and I'm going to actually get them both into slope-intercept form. I'm going to start with my first one, and I find out 2y equals 4x plus 16. Or that y equals 2x plus 8. When I look at my second one, it's written in point slope form, and I do see that these are for sure going to have the same slope. So I know at a minimum they're parallel, but just to be sure, I'm going to go ahead and get them in the same form. And so I'm going to take and distribute my 2. And what I notice is that when I add and get y by itself, I actually come up with y equals 2x plus 8. So these lines are actually going to be coinciding. Okay, last one, example F. In example F, they're wanting me to write an equation in slope-intercept form for a line that is perpendicular to y equals negative 2x plus 8, and it contains the point negative 3, 7. Sometimes I like to remind myself, slope-intercept form, y equals mx plus b, and perpendicular. Well, if this line has a slope of negative 2, would you agree that a line perpendicular to that would need to be the opposite reciprocal? So I would need one that is a positive 1/2. Now it's going to contain the point negative 3, 7. So I'm actually going to use my point slope and substitute that in. Y minus 7 equal to 1/2 times x minus a minus 3. And then I'm just going to do a little bit of simplifying. Y minus 7 equal to 1/2 x plus 1/2. I'll go ahead and add my 7. And we are going to find that in slope-intercept form, we have y equal to 1/2 x plus 8/2, which you could also write as 17/2. This tells me up 1/2, crossing the y-axis at 0.